Hi, today we're going to go over the steps of gel electrophoresis. So using the new to improve the old. So our knowledge of the structure and function of DNA is fairly new, basically developed by Watson and Crick in 1953. However, in a short amount of time, our DNA knowledge has been used to improve identification methods of criminals, determine maternity and paternity tests, and bioengineer products. Blood typing was the first used for some of these purposes, but it was limited capability because it's not specific to each person. So gel electrophoresis, DNA fingerprinting, every person has a unique sequence of DNA. If we use restriction enzymes, we can cut that DNA into pieces, and then we can look at the pieces and we can basically see what the different codes mean. So DNA fingerprinting is a unique picture of a person's cut up DNA fragments that are then separated by size, and they use gel electrophoresis in order to do this. So to create a DNA fingerprint, you're going to go through and use restriction enzymes, cut up the DNA. You're going to set those into a gel electrophoresis, and then you're going to let that run. And then you allow that to work, and you see how the pieces move, and then you can relate those pieces to information that you have, and you can compare it. And if you're trying to find someone who has committed a crime, you can compare it to the DNA that may be found at the scene, and then you can basically find out who did what. Okay, so this was an activity that you could do if you have shockwave. Not sure how many of us can do that, but tomorrow we're working with DNA, so DNA fingerprinting, so we'll do an activity similar to that. So here is what you are looking for. So your first thing is that your restriction enzymes cleave the DNA into smaller segments of various pieces. They cut it up. Your DNA sequences are then loaded into little wells in a gel, and the gel floats in a buffer solution, and that is in a chamber. And then you have two electrodes, a positive and a negative. So when an electric current is passed through the chamber, the DNA fragments move toward the positively charged end or cathode. And the smaller DNA segments move faster and farther than the larger DNA segments. So the ones that are near that positive end are the smaller ones. So this is a real electrode gel phoresis. And so here are your wells. So this is your cathode part, and this is how they're moving. So these are smaller ones. The short version of how DNA fingerprints are made: DNA is negatively charged. When you turn on the gel, the DNA samples move across to the positive side. And because the gel is porous, it contains little small holes, so the large fragments get stuck and don't move as far, and the small fragments can easily move through them and can move further along. So example 1, who left the blood stain and how do you know? So here is your blood stain. Here is the people that you're thinking caused that blood stain. So what you do is you compare them to the original version. And so if you look, the person who compares is John. So John left the blood stain. So who are the children of these parents? So we have a mom and a dad, and we have daughter 1, daughter 2, son 1, son 2. So we're going to look at this, and this is going to be a combination of the parents in order to basically determine the child. So here you have daughter 1 is mom and dad's here. It has dad's markings here and mom's markings here. Here we have an individual marking, one of mom's, individual, one of mom's, but dad's doesn't appear there. So here are dad and mom, dad, mom, and then we have nothing that is similar in this child. So it's probably going to be the children would be son 1 and daughter 1. So who is the father and how do you know? So we have the child, and we have Mary, which is the mom, and then we have Bob and Larry, which could be the dad. So Bob has only one thing in common, but Larry has 3 things in common, so Larry is probably the father. Who are the parents of this soldier and how do you know? So here's the soldier. So you compare them. These have a few that are in common. These have a few that are in common. So if I was looking at this and trying to compare all the different types, I probably would say that it would be very close to these guys being the parents. Okay, so that's gel electrophoresis.